Hello, in this video we are going to graph polynomial functions from factored form. The step process that we're going to follow is for each polynomial function we will state the end behavior, then we'll state the values of the real zeros, and then lastly we'll make a sketch of the graph. So that's what we aim to do in this video. For the first step, we are going to state our end behavior. So I'll put a. So we have first to identify our leading coefficient. If we have a negative coefficient, then we're going to have x-axis reflection. And here we do. We have a -1 leading coefficient. And then we need to determine the degree power of our function. So I have 1x, I have an x that is squared, so that counts as 2, so 1, 2, 3, and I have 4 here. So this is a quartic function that has a negative coefficient, so therefore it is going to be facing downwards and have end behavior that goes towards negative infinity. So therefore we can state our end behavior as x goes to negative infinity, f of x goes to negative infinity. As x goes to positive infinity, my outputs, my y values go to negative infinity. So this function is facing downwards. Part B, we want to go ahead and we want to determine our real zeros. So I'm going to write each factor. There's B. I'm going to write each factor and set it equal to 0. So negative x, I'll set that equal to 0. I'll take x minus 3. I'll set it equal to 0. I'll take, I have another. I'll take my x minus 3 squared. So I have another x minus 3 equal to 0, and then I have an x plus 4 equal to 0. Okay, so I want to go ahead, I want to solve each one for x. So I am going to go ahead and do that. Here I'll just divide this by -1, divide by -1, and I get x is equal to 0. Here I can add 3 to both sides, which will give me x is equal to 3. Same situation here, I can add 3 to both sides, so I get x is equal to 3. And that's kind of important here. So you wanna note that you have multiplicity with x equals 3, and then here I'm gonna subtract 4 on each side, giving me x is equal to -4. So I have my zeros. I have stated the end behavior, and now we're gonna go ahead and sketch our graph. So I'm going to draw my y-axis. And my x-axis. And I'm going to go ahead and plot my zeros and my end behavior. So my end behavior, I have a 0 at 0. I have a 0 at -4. 1, 2, 3, 4. and I have a 0 at 3, and this is multiplicity. So that'll be important when we start graphing. Now I'm going to go ahead and I'm going to graph my end behavior, which both are facing downwards. So as x goes to negative infinity, f of x goes to negative infinity, as x goes to positive infinity, f of x goes to negative infinity. So they're both down here. So I'll start here. I'm going to go through this point because there's only 1 0 there. I'm going to turn around. I'm going to go through this point because there's only 1 0 here. I'm going to turn around and I'm going to just touch this point and come back this way. So common question here is, why did we just touch this point? Why did we not go through it? Why did we touch it and head back around? Again, this is from our first lesson in the unit, and the reason is that here we have multiplicity. I have a even amount of zeros here, so that's why I touch it and head back this way. If it was an odd amount, we would pass through it, and if it was an odd amount, such as 3, 5, 7, anything greater than 1, it would be an inflection point there. Okay, so we have graphed our polynomial functions from factored form, and that is it.